On this channel, we often think in terms of geologic time rather than time as it is in relation to an average human lifespan. Here, we're more like rocks in our perception of time, or at least I am, thinking ahead billions of years. When trying to think in terms of 10 trillion chess moves ahead, there is one huge white elephant in the room as far as future events are concerned. That's the cosmologically semi-imminent death of the Milky Way galaxy. That's not as scary as it sounds. A galaxy is really just an arrangement of stars that is subject to change. It doesn't really matter so much to the individual stars of that galaxy, but we often intuitively think of our Milky Way galaxy as something that will permanently spiral its way through the universe, unaffected by the lives and deaths of the individual suns that make up its fabric. But this is not the case. The great familiar barred spiral that is our galaxy only has about 4 billion years to live, and its death will be as spectacular as things get. You see, we're set to ram headlong into the great Andromeda galaxy, and there is almost certainly nothing we can do about it no matter how advanced we get in the intervening years. And if that's not bad enough, the Andromeda galaxy is much, much bigger than the Milky Way. Our galaxy contains about 300 billion stars. Andromeda contains a trillion, so the merger will be more like a swallowing up of the Milky Way by Andromeda rather than the other way around. More, M31, as it is also known, is already so close that you can see it with the naked eye as a greenish-blue smudge in the constellation of Andromeda. That's because it's close in terms of how huge the universe is, at just 2.5 million light-years away. But it's getting closer. Fast, as in 68 miles per second fast. The collision speeds involved here are nearly unfathomable. But don't worry, space is an unbelievably huge place, and the distance between individual stars and galaxies are usually quite huge, barring solar systems with multiple stars already in them. So collisions between individual stars would be very unlikely during the event. Think of it like this: if you shrink stars in space down to the size of golf balls for comparison, the average distance between stars, even in the relatively dense galactic core, would still be similar to two golf balls separated by about 2 miles or a bit over 3 kilometers. That leaves lots of room for stars to pass by each other without colliding, but they will affect each other through gravity. Within the gravitational chaos, some stars will be ejected from the merging galaxies entirely to wander the darkness of intergalactic space alone until they burn out. But the bulk of the two galaxy stars will coalesce into a new galaxy. While no official name for the resulting galaxy has been adopted, the two current favorites are Milkdromeda and Milkomeda. But Milkdromeda won't be a beautiful new super spiral galaxy. That structure will be a thing of the past, but rather it will be a generally featureless and ho-hum elliptical galaxy, or with some luck a disk-type galaxy with maybe some remnant of spiral structure. A sad end indeed for both galaxies. But there is one exception to the highly unlikely collision rule. This one is highly likely. Each of the galaxies has at its core a supermassive black hole. In Milkdromeda, these two black holes will approach each other and eventually converge into a single supermassive black hole. It's unclear what this might do, though possibilities include the creation of a quasar or active galactic nucleus. So you may be asking yourself, what of Earth in this melee of impending galactic chaos? A model from 2006 does not bode well. As the supermassive black holes coalesce, the Sun could get caught up in the gravitational upheaval of it all, and is predicted to have a 12% chance of getting ejected, though that is subject to change, of course. But again, don't worry, getting ejected would take millions of years and have little effect on the solar system. Plus, the increasing luminosity of the Sun by that time will have long before boiled the oceans away, and the planet will be caught up in a runaway greenhouse effect so bad that the surface may be completely molten, awaiting the Sun to eventually expand into a red giant and swallow it up. Well, unless we're still around, and by that time are a galaxy-spanning Kardashev Type 3 civilization with the ability to save Earth and prevent the Sun's ejection with stellar engines and such. In that case, we will have just gained 1 trillion new stars to colonize in our great Milkdromedan empire. Well, unless someone else already has them, in which case they will command the energy of over 3 times the amount of stars that we do. Not good. Thanks for listening. I am futurist and science fiction author John Michael Godier, and I will go on record 4 billion years early and say that I, for one, welcome our new Andromedan multi-galactic empire overlords, and be sure to check out my books at your favorite online book retailer and subscribe to my channel for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.